Okay, so composition of functions. It's kind of a big idea. You're used to things like adding, subtracting, multiplying, dividing. That's what we're doing with the algebra of functions. But this is a little bit different. And it only really, I've ever seen it used in functions. So it's called composition. Anyway, so I'll explain the idea. They have a pretty good example in the book. And it says something like, well, I can tell you the cost of what it costs to heat your house if based on the temperature. Like if I knew the temperature for the day, then I can, figure out the cost of what it costs to heat your house. So it's a function based on temperature. The cost is based on temperature. And then you have something else that says, well, I can figure out the temperature based on what day in the year it is. I can figure out the average temperature for, what's today, March 1st. Figure out the average temperature. I have data that tells me that. And so I can figure out what, approximately the temperature is going to be based on what day it is out of the year. So then if I wanted to figure out the cost, I'm basing it on based on temperature, but then the temperature is based on the day, what day of the year it is, day of year. Okay? So the way we write this in the notation is we're saying it's the cost function based on the temperature function, which is based on the day of the year. I'll put D for day. Okay? That is one way to write the notation. Cost being one function, temperature being another function. This is what we call a composition. So we're putting an input into the temperature function. We say, okay, it's March 1st, here's the average temperature. Then we take that result, that output, and it becomes the input for the cost function. Okay? So then we base the cost function on whatever that temperature was. Okay? So that's the idea of the composition of functions. Now, here's how we write it. The notation is f. Say you have two functions, f of x and g of x. Those are common names for functions. So f of x and g of x. Then f compose. It's a little circle. It's not a superscript. It's in the middle, almost like a multiplication sign, but it's not a dot. It's like an open circle. It's like the degree symbol, but not up high. It's like in the middle. So f compose g of x. That's the symbol for composition. That little circle there means compose. You're going to compose f and g. Okay. It equals f of g of x. Now, some textbooks will use the brackets. I like the brackets. Sometimes they just use parentheses like f of g of x, like this. I don't really care which one you use, but you'll see both of those notations. Okay. Now, that's the notation for it. If you have trouble thinking about it with this notation, you can always change it over to this notation. So it says we're going to find what g of x is. We're going to go to some g function with an x value, figure out what it is, and then we're going to take whatever it is, and we're going to put it in the f function. Okay, and we'll show you how to do this. Domain is kind of a thing. If I have f compose g of x, which is f of g of x, first you have to find the domain of g of x. Okay, and then you have to make sure that g of x is in the domain of f. Okay, so the output from the first function has to be in the domain for the second function that you're composing it with. One other note, just f of x times g of x, that's not the same thing as what we're doing here. That is not the same thing as f of g of x. Okay? Those aren't the same thing. Just FYI.